Okay, that indentation is actually coming from the add child function. I didn't have this. Item drops didn't have this uncommented, and neither did this. I'm going to leave that the way it is, though, because it's helpful to know when we start a big call like that. Okay, with that said, here's the idea that I am thinking for what to do for this labeling of those nodes. The basic idea that I'm thinking is that if the tree does not have children, the label can refer to the tree property directly. That's what we are currently doing here. If the tree does have children, we have to manually set the name. So I want to explore this line of thinking and try out some ideas. This might be a disaster. This could be the perfect solution. I'm not sure, but we'll find out. So let's just take a look at this constructor. Okay, so we can already see that in this constructor, we've got this label.setText and then label.onTextChange, lambda being assigned. And then in our value tree property changed, we can see that we're doing that same label setText again. So we've already got some duplication of code happening. So we can most likely refactor this to have changing the label text and the lambda into different functions. So let's write a function to update the label text and set a function to change how the label works if the children has tree or not. So let's go to our header file and let's declare these down after getting them completed. Void update label text and void update label behavior. I think those are appropriate names, and let's stub them out. We'll just put it down at the bottom. Void TaskQueue item component update label text, and again void TaskQueue item component update label behavior. Let's do the same if tree.getNumChildren is greater than 0, set the label text thing that we did in the constructor, and swap out the usage where it's needed. I'm talking about this thing right here. If tree.getNumChildren is greater than 0, label.setText a certain way. Okay, let's get this update label text function working. So let's just copy this and we'll put it down in our update label. Make sure we have correct parentheses usage. And now let's swap that out in the appropriate places. We're just going to call update label text. So we can put that here. We can get rid of this chunk right there. And we can also do that here. Actually, we can get rid of this altogether and put that here. Let's get rid of this commented code. We don't need that. Let's tackle the update label behavior thing now. So if the tree has children, we're going to do one thing. If otherwise, we're going to do something else. So let's go down to our update label behavior function and get that happening. If tree.getNumChildren is greater than 0, we're going to do one thing. Else, we're going to do something else. If the tree has children, we will, let's see, we are going to refer, and we are not going to use a lambda callback, so we will say label.onTextChange. Whoops, what did I push? I pushed Command T for some reason. Okay, label.onTextChange equals null pointer. We're going to get rid of the lambda that we had presently assigned, and now we're going to get our referral on. Label.getTextValue.refer to tree.getProperty as value. We want the name property and our undo manager again. Owner.getUndo manager. Now for the if we do have children, we will not refer and we will use a lambda callback. So we will say label.onTextChange equals, we'll use the same one we had before. The same lambda thing we will do, oops. We will do tree.setProperty name, and our new value is going to be we're gonna extract the label's current text property, but if it includes that if it includes this 0/0 thing, we're gonna strip that out. So we will do label.getText.substring. we're going to start at the beginning of the string, and we're going to look for that first opening parentheses. Label.getText.index of, and we're looking for that parentheses. Like that. Okay. And we're going to get rid of any white space that's there. Trim, not here, trim end. So if there's any white space at the end, that's going to get rid of that. Let's see. Now we can do, we need our undo manager. And if we were referring previously, we need to unrefer to. So we need to go auto text equals label.getText, like this. And then we can do value. We're going to make it value. And we're going to refer to text value. And now we can do label.get, oops, let me spell that right, label.getTextValue dot refer to, and refer to this text value. So that's going to undo this guy right here. So now we can call update label behavior in our value tree removed. We can do that here, value tree child removed, update label behavior, and also update the label text. And then we can also do that here in this function. Let's go up to our constructor, and we're going to get rid of this. Now we're going to instead call update label behavior. All right, let's run it and see what happens. All right, let's add some tasks and see if it still works as expected. Spinning wheel. Oh boy. Up. I think we got that same recursion issue that we had before. Okay. So we should figure out where that is coming from. Ah, my fault. So we're not supposed to set the text value inside the label.onTextChange. That's my fault. We're only supposed to change the tree property when the label text changes. Okay, let's try this one more time. All right. Oh, okay, there we go. We're adding tasks. Everything is good to go. Let's try doing a drag. We'll drag task 3 onto task 0. And let's try renaming task 0. Edit. Enter. Well, that's weird. Deleted the name. That's no good. So let's use these indent debug statements from TaskQueue and see if we can gain anything from it.